Welcome everyone to the maths class. In the last session, we have completed the basic calculus. And in today's session, we are going to start a new topic, which is vector calculus. So till now, we were doing some differential and integration operations on the functions, which are like normal functions. But in this chapter, we will be dealing with the differential and integration operations on the vectors. Okay. So before we jump into the differential operations and integration of vectors, I would like to give some small recap of what we have studied maybe in 12th or during first year of engineering. Just a basic knowledge of vectors, what is dot product, what is cross product, and how vectors will help us to calculate the area of triangle and area of the parallelogram, etc., etc. Okay, so that then studying vector differentiation and integration will be a little bit easier for us. Okay, so with that introduction, let me go to the next slide and write down heading vector calculus. Suppose if we have any point P, okay, if we have any point P whose dimensions are x comma y comma z in general, okay, so the position vector of P is basically it's a line joining the origin, which is of the coordinate system, to the point P, and this r bar is the position vector, and it is, we know it's represented by xi plus yj plus zk, where x, y, z are the coordinates of that point P, and mod of r is the magnitude of this vector. Okay, and that is under root of x square plus y square plus z square. Okay, this arrow indicates here the direction of the vector, whereas this length of the vector is calculated by mod of r, or magnitude of r, you can say, and which is under root of x square plus y square plus z square. Then this is just a single vector. Okay, for example, if we have two vectors, then let's say a1 is a1i plus a2j plus a3k, and b bar vector is b1i plus b2j plus b3k. Then we have a dot product of two vector and a cross product of two vector. Okay, so basically the cosine angle and just a minute, let me share my screen again. Yeah, so dot product of two vectors a dot b is basically a bar dot b bar, a bar mod of a bar into mod of b bar times cos of a bar cos a bar dot b bar. So basically it's like a cosine component, we can say, and in dot product we just multiply the components of in the I direction. I means x direction, y direction, and z direction. So it will be a1 b1 plus A2 B2 plus A3 B3. So the outcome of this will be the scalar quantity. Okay. Whereas the cross product, the outcome of the cross product is the vector quantity, and that will be perpendicular to these two vectors A and B, and it's given by A bar mod of A bar into mod of B bar sine of A bar dot B bar into n cap, whereas n, as I said, n cap is the vector which is perpendicular to the plane containing A bar and B bar. Okay, so these things we know already. I hope you know how to calculate the A bar cross B bar in reality. So it's like a ijk A1 A2 A3 B1 B2 B3. Okay, um, these are the components along x y z direction, and if you take determinant of it, you know, you'll get the cross product. Okay. um, as I said before, vectors are helpful for us to calculate the area of the triangle. Okay, suppose OA bar and OB bar are the two vectors. OA bar is given by A bar and OB bar is given by B bar. Okay, then half of A bar cross B bar will give you the area of the triangle. Okay, where A bar and B bar are the position vectors. Position vectors means they are passing through the origin O. That's why I am writing directly A bar and B bar. Okay, but suppose these 3 points are somewhere randomly in somewhere in the coordinate system x, y, and z. Okay, then each point will have some position vector. Position vector of A is A bar, position vector of B is B bar, and position vector of C is C bar. Okay, what is the position vector? It's a vector or the line um, um, which has a direction from origin to that point C, and the magnitude will be the distance from the origin, right? So this will be the position vector of the C, position vector of B, position vector of A. Okay, for like this. So A bar, B bar, and C bar are nothing but the position vectors of point A, B, C. If it is the case, then um, the area of the triangle is again AB bar cross AC bar. Okay, but what is AB bar? It will be B bar minus A bar. Okay, and what is AC bar? AC bar is C bar minus A bar. Okay, that's all. So that's how you will calculate the area of the triangle. If you directly know the vectors A bar and B bar, you can directly use this. Okay, because A bar and B bar itself are the position vectors here. But in second case, we don't know what is AB bar. Okay, and what is AC bar. So that's why we have used AB bar is equal to B bar minus A bar, and AC bar is equal to C bar minus A bar. Okay, so here this is the difference in between these two approaches. Okay. Let me check if we have any other point. Not getting. Can you see my screen? Okay. Try again. Okay, let's try the otherwise later I'll change my some network settings. Let's try one more time. So apart from the use to calculate the area of the triangle, we can use vectors to find the area of the parallelogram as well. Okay, we can use the um, vectors to calculate the area of the parallelogram as well. So where A bar and B bar, suppose they are the adjacent sides of the parallelogram, then mod of A bar cross B bar gives us the area of the parallelogram. Okay, yeah, it is just half. It is just the 2 times what we have studied as the area of the triangle, because here also we were targeting the adjacent sides. Okay, so if you just multiply with the 2, 2 will get cancelled, and mod of A bar cross B bar will be the area of the parallelogram. Scalar triple product. What is scalar triple product? A bar dot B bar cross C bar is a scalar triple product, and that is nothing but again mod of A bar B bar C bar. You can write it like this: A1 A2 A3, B1 B2 B3, C1 C2 C3. Okay, and why this is helpful? Because this will give us the volume of the parallelepiped. Okay, this will be the volume of the parallelepiped. And 1/6 of the scalar triple product will be the volume of the tetrahedron. Okay, this is just for your general understanding. These type of questions you may not get in exam. You will be like getting questions mainly based on the differentiation and vector differentiation and integration. But just to know, like the basic operations and use of vectors in real words, I'm just giving this basic information. Okay, so yeah, at least we know that there is some terms called as position vector. There is some term called as the dot product and cross product. Yeah, okay. Magnitude of the vector, direction of the vector, right? So these are the basic things you should know to learn the vector differentiation and integration. Okay, any doubt till this? At least these 4-5 points you understood. So if it is the case, then we can proceed for the vector differentiation, and later we will start vector integration maybe in the next class. Okay, so write down heading vector differentiation. Okay, I'll go through the definition or the approach here. Suppose r bar of t is let's say a vector equation of the curve. Okay, so look at this figure here. This figure is let's say a curved figure. Let me just draw it with a red pen. Okay, this is the curve we are saying. This curve is represented by r bar of t, or you can say it as f bar of t as well. Then if you differentiate, so we know if we have a simple curve and at particular point if we take a derivative of the function, we'll get the tangent to the function, or basically slope at that point, right? So same thing here. So in this vector calculus also we'll have same thing. We will be getting the tangent to the point where we are differentiating. Okay, so dr bar by dt represents the vector differentiation. It means limit delta t tends to 0, change in the function with respect to the delta t, right? So same thing um, as what we do in the derivative of the normal functions, but here just f bar, I am saying bar represents the vector function. Okay, so dr bar by dt represents a velocity vector at a point t um, when the particle is uh, or you can say the velocity of the particle at time t. Okay, so I'll repeat. Suppose if you have a particle which is following this curve c, okay, and it's represented by f of t, the curve, and the r bar of t is the vector, and if you take a derivative of it, dr bar by dt, you are going to get the velocity vector at that time. Okay, yeah. This is just the basic operation. Um, if you have, let's say, two vectors in addition, a bar plus or minus b bar, then differentiation of that will be, you have to separately differentiate them and then add or subtract them. Okay, similarly, if we have two vectors which are in multiplication, same approach, differentiation of first vector, second vector as it is, plus differentiation of first vector, second vector as it is. Okay, um, next one is if we have, so this was for the dot product. Okay, we have dot product, and this one is for the cross product, same approach. Okay, um, first function differentiation cross b bar plus first function as it is cross product of the second function. Okay, and if we have a scalar function phi which is in multiplication with the vector function, then also approach is more or less same. We have to differentiate scalar function keeping vector function as it is, plus keep scalar function as it is, differentiate the vector function. Okay, these are some basic rules. Okay, what is scalar what is scalar point function? Point functions are of two types basically. Either it can be a scalar point function or the vector point function. Um, what is the definition of the scalar point function from this figure? Anyone? Okay. So in simple words, scalar point function is defined as a function which assigns a real number to every point of the region in the space. Okay, so I have given some region here, and I have drawn 2 points here. So corresponding to each 2 points will have one real number, or the scalar value will have. Okay, so that function will assign some real number to every point in the part of this region. Okay, um, but what is this vector point function? Okay, um, the velocity at any point t of a particle in a fluid flow is a vector point function. Okay, so let's say this is the fluid flow. We don't know, okay, how fluid is flowing. Let's say randomly as shown here, and you take any point and take the calculate the velocity. Then um, so basically at each point you will have a different vector, um, and um, then that kind of function we have to say it as a vector point function. Okay, I hope you understood. In the first case, I can say, let's say, a temperature. In temperature, if you have some hot pot with you, just just confirm me if you are able to hear me. I have changed my network settings now. I hope it will work fine. Now, can you hear me and see my screen? Yes, okay. Okay, so scalar point function, as I said, it's like a temperature field. Okay, suppose if we have some plate or some material with you, and at each point we have some different temperature value. Okay, so as I shown here figure, in this figure, let's say at one point we have temperature of 50 degrees Celsius, at another point 60 degrees Celsius. So basically at different points we have different um, value of the function, right? So that kind of function we can say it as a scalar point function. But if we um, let's say a function is giving us a vector field. For example, the fluid is flowing somewhere, and the velocity at any point, if we calculate, of any particular particle. Okay, so as I'm showing here, we have a particle which is taking this random curve, and if you calculate the velocity at any point, you will get a vector actually, right? So this kind of function is called as a vector point function. Okay, so simple examples are like temperature is a scalar point function, whereas the velocity of fluid flow is a vector point function. Okay, now coming towards the major part of this vector differentiation is what is a vector differential operator. So generally, whenever we are dealing with the vector differentiation, we use operator del. Okay, write down the symbol. We use this operator del. What is del? Del is I times dou by dou x plus j times dou by dou y plus k times dou by dou z. Okay, so this is the differential operator for the vector. Whenever you are, so now you know the vector point function and the scalar point function, right? So if f is a scalar point function, right, and you are applying del operation on it, then you can say it's a gradient of f. Okay, what is the gradient of f? If you are performing a differential operator, or if you are applying the differential operator on the scalar potential function, scalar um, point function, then it's a gradient of f. But if you are applying differential operator on a vector function, then it's a divergence of f. Okay, so what is divergence and all, we'll discuss later. First we'll start with a simple gradient term. Okay, so let's start first with the gradient. As I said, I'll bring this divergence later, okay, and give a detailed explanation on it. As of now, we'll start with basic first, that is a gradient of f. So what we are doing is we have a scalar function, okay, and you are trying to find the gradient of it. Okay, so it's a simple example, temperature gradient, right? If we have two walls and the uh, two walls are made up of some different material, and then there will be some temperature gradient if they are exposed to the um, uh, if one of them is exposed to the heat, for example. Okay, so what is gradient? Basically it's a difference, okay, or it means the differential operation we are performing there. So del f means the gradient of f, where f is a scalar point function. Okay, so let's understand here, like phi is a differential scalar point function, then gradient of phi is denoted like this. Okay, gradient of phi is denoted like this, that is del of phi. Okay, del bar of phi. Del bar, you can see it's because it's a ijk we are using here. So phi here is like a temperature field. You have taken one, for example, a plate which is made up of some kind of material, okay, which is having varying coefficient of thermal expansion, and for example, one end of that material is exposed to the heat, and then obviously you will see more temperature near that section, and some other section will have less heat. Okay, so there will be some gradient um, in the um, temperature, okay, temperature field. So yeah, and as we are dealing with the scalar point function like temperature, we have to say it's a gradient of the scalar function. Okay, so what is the outcome of it? The outcome of it is a vector. Basically it will give us how the temperature field is varying, and in which direction it is varying. Okay, so um, del of phi will give us the vector. Okay, del of phi is like I times dou phi by dou x plus j times dou phi by dou y plus k times dou phi by dou z. Okay, so this is the outcome of the gradient of scalar function is a vector function. Okay, and if you want to calculate the unit vector function, then that will be like this, del of phi divided by mod of del phi. Okay, del of phi divided by mod of del phi. Okay, let me give you some simple example to make this concept robust. Okay, um, can I go to the next slide? Okay, take this question. The unit normal vector or unit normal to the surface y square is equal to 8x at 1 comma 2 is okay. um, as I said previously, that the gradient of phi will be the normal to the surface phi. Gradient of phi will be the normal to the surface phi. It means if we have any scalar point function phi for a surface, okay, so in this case the surface is um, y square is equal to 8x, means phi is equal to y square minus 8x. Okay, then uh, del of phi will be I d phi by dx plus j d phi by dy plus k dou phi by dou z. Okay, and differentiation of phi with respect to x is minus 8. Differentiation of phi with respect to y is 2y. J and differentiation with respect to z is 0. So, and later if you put 1 and 2 values, you will gonna get this is your del phi, and it's a del phi or del bar of phi, you can say. And at 1 comma 2 it will be minus 8i plus 4j. Okay, and they are asking us the unit normal vector, means normal unit normal vector is of phi is del phi bar divided by mod of del phi bar. Okay, it's minus 8i plus 4j divided by under root of 8 square is 64, 4 square is 16. Okay, so this minus 8i plus 4j divided by under root 80. Okay, yeah. Yeah, this is the one. Clear? So let me give some questions on this and you try to solve it. We'll go to the next slide and give you a question. You tried. A sphere of unit radius is centered at origin. Okay. The unit normal at centered at origin. The unit normal at point P is x comma y comma z to the surface of the sphere, to the surface to the surface of sphere is the vector, and the options are like 1 by root 3 comma 1 by root 3 comma 1 by root 3, and B is like x by root 3 comma y by root 3 comma z by root 3. Option C is x comma y comma z. Option D is x by root 2 or x by 3 comma y by 3 comma z by 3. Okay. Yeah. Solve this question. I'll wait for 2 minutes and you try to solve it.
Option C, sir.
Yes, yeah, option C is correct. Yeah. Yes, so let me help you with this. X square plus y square plus z square equal to 1 is the equation of the sphere with a unit radius and centered at origin. Okay, so phi is your scalar function, and which is written as x square plus y square plus z square minus 1. Okay, and del of phi is the the gradient of phi, and we can calculate it as directly. I'll write differentiation with respect to x of phi, that is 2xi differentiation with respect to y is 2yj, and differentiation with respect to z is 2zk. Okay, this is how we can calculate, and this will be the normal to the surface. Del of phi, and they are asking us the unit normal, right? Del of phi divided by mod of del phi is 2xi plus 2yj plus 2zk divided by under root of 4 times x square plus y square plus z square. X square plus y square plus z square is 1, so under root of it will be 1 again, and root of 4 will be 2, and 2 will get cancelled out, so ultimately you will get xi plus yj plus zk. Okay, so it means x comma y comma z, hence option C is correct. Yeah. Okay, one of the similar concept is directional derivative. Okay, so this is also a very important concept, directional derivative. Write down heading directional derivative. Okay, so what is the meaning of the directional derivative? Is the rate at which any function changes um, at any particular point in a particular direction. Okay, function changes uh, at any particular point in a fixed direction. Okay, so this is nothing but the directional derivative. So if you want to calculate the directional derivative of the function, so directional derivative of the phi of x comma y comma z is given by the first of all, in which direction we want in the direction of a bar, right? So what we want is how the phi is changing in the direction of a bar. Okay, so that is the meaning of it. Okay, I hope you understood. In particular direction we want to understand how the the function is changing, and that is given by directional derivative. Okay, a simple example. Okay, if we have a temperature field and in particular direction you want how the temperature is changing, then it means you are interested in directional derivative. Okay, you want to understand at which rate the function is changing in that particular direction. Okay, so directional derivative, as I said, it will be the gradient of phi, right, dot product with the unit vector in which the rate is desired to be calculated. Okay, I hope you understood. So a bar is the vector, or a bar is the direction in which we are interested um, to understand how our function is changing. So a bar divided by mod of a bar will give us the unit vector in the direction of a bar. Okay, so this will be the unit vector in a bar. Okay, and del of phi will be the gradient of phi. Okay, a dot product of that will be your directional derivative. Okay, um, So for example, if a bar is I only, okay, a bar is I, then its directional derivative will be like dot product of I with respect to the del of phi, and you will just get dou phi by dou x, because all other terms will become 0. Okay. Yeah. So for example, let's say um, let's take some questions, so this concept will be more robust. Mm, okay, so I think that's enough we have, and one more point is angle between two surfaces. Okay, all these points are related to the gradient, so that's why I'm taking them. Angle between the two surfaces, suppose if you have surface phi1 of c1 c2, sorry, phi1 of x1 comma x2 comma or x comma y comma z is equal to c1, and another function phi is x comma y comma z equal to c2. Okay, so these are the two um, surfaces. Then the cost product between them is uh, del phi 1 dot del phi 2 divided by mod of del phi 1 del phi 2. Okay, so this is how you will calculate the angle between the two surfaces. Okay, note down this point as well. Coming towards the next point, let's take some questions related to these topics. Directional derivative of f of x comma y is equal to x square minus y square at 1 comma 2 in the direction of 4i plus 3j is. Okay. The options are 4 by 5u, 3 by 5u, minus 4 by 5u, minus 3 by 5u. Okay, solve this question.
Option C, sir.
Yes, option C is the correct. So as I said, directional derivative will be the gradient of the scalar function and the dot product with the direction in which it is desired to be calculated. So it's a unit vector in that direction. So a bar divided by mod of a bar will be the unit vector. So here a bar is given as this. This is your a bar, and del of phi is 2xi plus minus 2yj. Okay, you have to calculate at 1 comma 2 dot product with 4i plus 3j divided by under root of 4 square plus 3 square is 5. Okay, so it is in short 2i minus 4j dot product with 4i plus 3j divided by 5. So if you take a dot product, it is 8 minus 12 divided by 5. It is minus 4 by 5. Okay, yeah. So option C is correct in this case. Okay, let me give you another question. Directional derivative of x square minus y square plus 2z square at point 1 comma 2 comma 3 in the direction of PQ. Okay, this is P at P, which is 1 comma 2 comma 3. Okay, sorry, screen is um, yeah, PQ, which is where Q is 5 comma 0 comma 4. Okay, directional derivative of a function x square minus y square plus 2z square at point 1 comma 2 comma 3 in the direction of PQ, where Q is 5 comma 0 comma 4. Okay, solve this. Solve this question. Options are like 9 by root 14, 18 by root 14, 16 by root 14, and option D is 12 by root 14. No, Arjun. Mm, or you can no. In denominator, you should get root 14. Check it once again where you are done a mistake, or let me help you out with this. Oh, no, sorry. I have given wrong options. Give me a minute. These are the options for the next question. Yes, Arjun, 28 by root 21 is the correct answer. Okay. Let me just
Yes, sir.
rub it. 28 by root 21 is the correct answer. Yes.
That only, yeah, I got, yeah. Okay.
Yeah. Here the difference is they have given point P and Q. Okay. So they are indirectly they have given you the PQ bar. So what is PQ bar? It's a 5, 0, 4 minus 1, 2, and 3. So it's basically 4i minus 2j plus k. Okay. So this is your PQ bar. Okay. Indirectly they have given you. So in this direction, you have to find the directional derivative. So what is the unit vector in this direction? It is PQ bar divided by mod of PQ bar. Okay. And that is uh, yeah, its value is, and at which point we are supposed to calculate at P 1 comma 2 comma 3. So yeah, at this point we are supposed to calculate the directional derivative. But what is unit vector in this direction? It will be 4i minus 2j plus k divided by under root of 4 square is 16 plus 2 square is 4 plus 1. So divide by 21, you will get for sure. Okay. And so directional derivative will be del of phi into 4i minus 2j plus k divided by root 21. What is del of phi? Um, um, del of phi is 2xi minus 2yj plus 4zk. Okay, this is del of phi, but at point 1 comma 2 comma 3 its value will be how much? 2 2i minus 4j plus mm, how much? 12k. Okay, 2i minus 4j plus 12k is the uh, del of phi, and if you take dot product with this, how much you are gonna get is 4 into 2 is 8 plus uh, minus 4 into minus 2 is 8 plus 12 into 1 is 12. Okay, divided by under root of 21. So it's a 28 by under root of 21. Okay, this is the answer. Next question, you can try for this homework. You try it for homework. Directional derivative of phi or directional derivative of f, which is xy square plus yz square plus zx square along the tangent to the curve x is equal to t, y is equal to t square, and z is equal to t cube at 1 comma 1 comma 1 each. Okay, and the answer in this case is 18 by root 14. Okay, you try it whenever you have some free time. Hint, here phi function is already given, so in this case it is f. Okay, uh, only thing is they have not given you the a vector, right? A bar they have not given. A bar they have given you indirectly. What indirectly they have given? It's a tangent to the curve x equal to t, y is equal to t square, and z is equal to t cube. So this is what they have given you indirectly. You should know how to calculate um, I hope you are able to hear me now. So what I was saying is, you try this previous question for homework with a given hint. R bar I have given you, that is ti plus t square j plus t cube k, and tangent to the curve will be dr bar by dt. Okay, so that is what I have explained for the previous question. For this question, I have just given you, try to solve it and tell me the answer, like, or at least tell me the approach. You can try it later whenever you get free time. Okay, this is again for homework. I'll give you answer, but in this question I'll not give you hint. I want you now to tell me what is your approach. What phi they have given you, so that is not an issue. So only thing is they have not given you a, right? A bar. So how you will find a bar? That is my question. How you will find a bar? Anyone? What is the value of a bar? Okay, just to give you small idea, this is your x-axis, this is your y-axis. What they have said, they want a directional derivative along the line which makes 30° with x-axis, positive x-axis. Okay, so in this is your a bar basically. Clear? So how you will convert it into the proper vector? Okay, from how you will convert this diagram into the vector? See, this, let's call it as a bar. A bar will be something xi plus yj, right? So it is, yeah, xi plus yj, right, Arjun? So what is x? X will be, um, let's say a particular any point. Take any point here. Let's say x comma y, and let's call this as r, which is a point, which is the magnitude of this. Okay, uh, let's call this r bar rather. Okay, to make it more familiar, familiar term. And now, um, r bar will be, what is x? X will be r cos of theta I plus y will be r sin of theta j. And if you take, what is this r? This is the magnitude of r basically. If you take it on the left hand side, I can write it like this. Cos of theta will be cos 30 degrees root 3 by 2, and sin 30 degree will be 1 by 2. Okay, like this. Okay, so this is the hint. With this hint, you should be able to calculate it. Arjun, minus 1 by 2 you should get. Take again, maybe some small mistake you might have done. Minus 1 by 2 is the answer in this case. Okay, yeah, you can try it later. But yeah, more or less your answer looks correct. Okay, another question, like, which you can solve, indirect way of asking it is like, in some cases, like, what they'll ask is like this: the greatest rate of increase of phi is equal to x square yz at point 2 comma minus 1 comma 2 is. Okay, so what is the indirect way of asking it? This is the indirect way of asking, use the gradient. Okay, basically greatest way of increase of phi or the maximum value of the directional derivative. These kind of terminologies also they can use. What is the maximum value of directional derivative? Can you tell me?
Mod of del phi. Mod of del phi.
Mod of del phi, right? So it's yeah, basically it's a mod of del phi, correct. And later we are like in order to get the directional derivative, we are calculating its dot product. So if I say maximum value of the directional derivative, and if I say the greatest rate of increase, these are similar terms, right? The greatest rate of increase, because what is the directional derivative? Directional derivative is the rate at which function is changing in some particular direction, and the greatest rate of will be the del phi only. So um, maximum value of the directional derivative will be again del phi. Okay, so these kind of terms, if they use in the exam, they are just asking you the gradient of phi, that's all, nothing else. Okay, so they are just asking you mod of del phi, and so you have to first calculate del of phi and take a mod of it. So del phi will be equal to 2xi, sorry, 2xyzi plus x square zj plus x square yk. Okay, and then at what point you want this del of phi at 2 comma minus 1 comma 2. If you calculate, it is minus 8i plus 8j minus 4k. Okay, and then mod of del phi will be equal to under root of minus it, which is 64 plus 64 plus 16. So it's under root of 144, which is 12. Okay, so this is also a type of another type of question which you can get. Okay, but don't get confused with the scope. It's same thing. If they use the words like greatest rate of increase of function, or the maximum value of the directional derivative, or the gradient of a scalar point function, it's all are like same things. Okay, one last question from this type. Here I'll give uh, angle between surfaces x square plus y square plus z square equal to 9, and x square plus y square minus z equal to 3. Okay, what are the surfaces? X square plus y square plus z square minus 9 or equal to 9, and second one is x square plus y square minus z equal to 3. Okay, so angle between these surfaces is what you have to calculate. If you remember the formula, cos of theta is equal to del of phi 1 dot del of phi 2 divided by mod of del of phi 1 into del of phi 2. Okay, this is the formula which you have to use. So theta will be cos inverse of this. Okay, so I think you should be able to solve it. I'll give you 2 minutes of time. You can solve and tell me the answer. Okay. Cos inverse of 8 by 3 root 21 is the answer. Okay, this is the answer. Yes, okay. You try it, it's not that difficult, okay. So I'll write here it's a theta is equal to cos inverse of 8 by 3 root 21. Okay. Del phi 1 bar is like uh, 2xi plus 2yj plus 2zk. Okay. It's a dot product with yeah, I think I just missed to give that one more point here, or not written. They are asking at 2 comma minus 1 comma 2 point. Okay, at this point they are asking you the angle, and what is del of phi 2? Del of phi 2 will be again 2xi plus 2yj, but minus 1k. Okay, so minus k directly, and so if you put the value of x equal to 2, y is equal to minus 1, and z is equal to 2, this will become 4i. This will also become 4i, right? This will become minus 2. This will also become uh, minus 2. And this will become 4 plus 4. And this will, yeah, that will remain same. And divided by under root of, let's say, 4 square is 16 plus, again 4 square is 16 plus 4 is 36. And here phi 2 is 4 square plus 2 square, that is 16 plus 4 is 20 plus 1 is 21. Okay, so if you further solve it, you should get 8 divided by 3 root 21. Okay, you after solving it. So that's why theta is equal to cos inverse of 8 divided by 3 root 21. Okay, this is the angle between the surfaces x square plus y square plus z square equal to 9, and x square plus y square minus z equal to 3 at point 2 comma minus 1 comma 2. Okay, so this is what variety of problem you can expect when it comes from the divergence of a gradient of a scalar function. Okay, gradient of the scalar function is del of phi. Okay, so either they will directly ask you to calculate the gradient, or they will say directional derivative, maximum rate of change. These are the terminologies they can use. Okay, or they can ask the questions related to the angle between surfaces also. Okay, so that's all about the gradient part. Coming towards the another point, which is divergence of a vector. Okay, so if you are performing the del operation on the vector field, okay, or vector function, so look at here, we got f bar, which is a vector function, f1i plus f2j plus f3k, and we are performing now del operation on it. So both are the vector. Divergence of a vector is a del dot f bar. If you take a dot product, you will ultimately get a scalar quantity out of it. Okay, so dou by dou x of f1 plus dou by dou f of x2 plus dou by dou z, dou by dou y of f2 plus dou by dou z of f3. So this is what you are going to get. Okay. And what is a curl? Divergence and curl are related to each other. So what is curl? Curl is a cross product with f bar. Okay, so f bar is again the vector field or the vector function, and if you take a cross product between them, it is a curl of a vector. Okay, divergence is a dot product, curl is a cross product. What is the practical use of it, or what is how practically this is visualized? So if you look into this vector field, it is a rotating vector field, you can say. Okay, all the vector at all points the vectors are rotating, right? But they are not diverging. Look at this point function, or this one here. They are like diverging from each other. Okay, so this field is diverging from the center, but are they rotating? No. So this is like a irrotational vector field, but it's diverging. But if you look into this vector field, it is like it's a rotating also, it's a diverging also. Okay, so in order to analyze like the given vector function or the given vector field, how it looks like, whether it's a rotational, whether it's irrotational, whether it's diverging or not, and that is what we can understand by using this divergence and curl. Okay, if the curl is zero means cross product of that cross product with the del operation is zero. It means it is not rotating, and that, so you can call it as an irrotational vector. Okay, if del cross f bar is zero means f bar is an irrotational vector. Okay, and if del dot f bar is zero, then you can call it as a solenoidal vector, means it is not diverging. Okay, so look at this, it's a let's say solenoidal vector field. In this case you can say it's not a diverging. I hope you understood how divergence and curl is helpful for us to visualize the vector field. Any doubt in this? Is it clear to you how the divergence of vector and curl of a vector can be calculated? Another point related to this is suppose take a let's say omega is the angular velocity. Okay, if you take a right hand thumb rule, angular velocity vector omega will define by a thumb, and um, uh, okay, and the other fingers represents the um, uh, for okay, other fingers represents um, the direction basically. Okay, or you can say the field itself. And what is b bar? B bar is a velocity vector. And how we calculate b bar? B bar is omega bar cross r bar. Okay, where, or we know that v is equal to r omega, we say, right? So v bar is like omega bar cross r bar. It's a cross product of the in the vector field. So in general, what we say, velocity is equal to angular velocity times the r value, right? A distance value. So same thing here, but in vector form, v bar is equal to omega bar cross r bar, and it means what we are saying is it's a curl of v bar. Okay, so if you take a curl of v bar, so it means you are trying to check whether that v bar is rotational or not. Okay, um, and curl of v bar is curl of omega bar cross r bar, and you can write it as a del cross omega bar cross r bar, and that is 2 omega. How it is calculated, I'll explain. So in short, omega bar, you can say it as half of curl of v bar. Okay, so in short, you might have studied this in physics or something. that is angular velocity vector is equal to the half of the curl of velocity vector. Okay, um, or half of the del cross v bar. Okay, so this is the formula. It's a well-known formula. Coming back to this, why this 2 omega came here, how this how this 2 omega came here. So this term I am writing as it is, del cross omega cross r. So if we take a vector multiply, if you perform the vector triple product, you will get del dot r times omega minus del dot omega times r. Okay, and in this case the del of omega is 0. Okay, because yeah, omega is angular velocity, and yeah, it's a derivative, we are going to get 0. And now yeah, del of r, if you further simplify it, like what is r? R is xi plus yj, and take a del of it, dou by dou x of x plus dou by dou of y, so it's 1 plus 1 and 2. Okay, so ultimately, let's not go into this detail, but this relationship you should know. In short, what I'm trying to explain is, if angular velocity vector is to be calculated, it is half of the curl of the velocity vector. Okay, so this is the relationship between the angular velocity vector and the velocity vector of a particle. Okay, we got a question from Arjun here. For solenoidal, y dot product, and for rotational, y cross product. Okay, let me think on it. So basically, Arjun, if you remember, what is a bar cross b bar? A bar cross b bar is like a sine component, right? Mod of a bar, mod of b bar, sine component of that. So if we have a vector in which you have, let's say, you don't have sine function or sine component of it, right? With respect to the direction of the vector, it means that vector is not rotating. Okay. Um, so what is sine component of a horizontal line? It's 0, right? Um, so that is what we are trying to explain here. If this is 0, it means we are talking about the horizontal lines, okay, which are not rotating. Okay, in particular direction they are just going. But if they are making some angle, then in that case, obviously, you will end up with a sine component of it. Okay, so that's why we are using this cross product with the for the curl. Okay, I hope you at least got some idea about it. Okay, but yeah, these two things are very, very important. Whenever you come across a vector field, you have to check the dot product and cross product. Dot product is nothing but the divergence of the vector. It will tell you whether the vector field is going away from the center or not. If it is going away from the center, means it's diverging, and cross product is nothing but the curl of the vector, which will help us to understand whether the field is rotating or not. Okay, yeah. So these are the two main points you should remember. And this is another just note which I have given, which is related to the curl, that angular velocity vector is half of the curl of linear velocity vector. Okay, and some of the points to remember. Okay, if you just solve, if you don't, we will not derive it, but just remember it now, because they are just thumb rules. Curl, gradient of phi, right? Gradient of phi, and if you take a curl of it, it's going to be a 0. Okay, um, gradient of phi, curl of a gradient of phi is 0. Okay, um, so basically gradient of phi, what it gives us, it gives us a vector, right? It gives us the vector, means where we have maximum change, and then if you take a curl of it, it's going to be 0, because it's not a rotational field, it's a straight line, right? So that's why curl of a gradient of phi is 0, and divergence of curl of f bar is also 0. Okay, divergence of curl of f bar is also 0. So these two thumb rules you should know. Um, Sometimes they will give one question where they'll give you a bar and they'll ask you to calculate divergence of curl of f bar. You can try it, but ultimately you're going to get 0. Okay, so um, if you know you can still derive and get 0. That's not a problem. But just to save time, you should just remember these two thumb rules. Okay. So what is scalar potential function? For every irrotational vector. What is the meaning of irrotational vector? Means the vector for which curl exists. Okay, scalar phi exists. Okay, for every irrotational vector, the scalar function phi exists such that a bar is del of phi, then the phi is said to be a scalar potential function. Okay, then that phi is called as a scalar potential function. So try to understand here what they are what they are saying. When we say irrotational vector means um, that vector has a curl, okay, or non-zero. It means the curl of that vector is um, not 0, right? And so for every that irrotational vector, a scalar function phi exists, okay, such that f bar is del of phi, then that phi is said to be a scalar potential function. Okay. So that is what they are trying to explain through this. What is scalar potential function? Okay. Before we jump into some more theoretical concepts, let's try to solve some more questions on it to concrete this understanding of um, divergence and curl. Okay, let me give you some questions now. Just give me a minute. Yeah, take a question. If f bar is equal to 3x square plus 2y times I minus 4xz times j plus plus 3 xy square time k, okay, uh, is the velocity vector then corresponding angular velocity at point 2 comma 2 comma minus 1 is corresponding angular velocity at point 2 comma 2 comma minus 1 is, okay. Solve this question. It's not that difficult. So direct formula based question. Yep. Mm, the formula you remember, Arjun, like in between angular velocity. Okay.
16 I cap minus 6 j cap plus k cap.
Yes, correct. This is the formula we should be using. The omega bar answer here is 16i minus 6j plus k. That's correct answer. So half of curl of what is curl of f bar first of all? Is I j k dou by dou x dou by dou y dou by dou z. Okay, 3x square plus 2y minus 4xz 3xy square. Okay, solve it, take a determinant, you will get 32i minus 12j plus 2k, and here just multiply with 1 by 2, you are going to get this final answer. As simple as it is. Okay, some small questions. Quickly tell the answers for these. Pi of x comma y is equal to ax square y minus y cube, and pi square phi del square phi is equal to 0. Then a is equal to, okay, options are 2, 3, minus 2, minus 3. Okay, this is the one. And f bar is equal to, this is the first question, you try solving it. Pi x plus 7z square I plus 4x square plus lambda y times j plus 7z minus 2xyk, okay, is solenoidal. Then lambda is equal to, okay, options minus 12, 12, 6, minus 6. Okay. First one B, correct. 3 is the answer. Correct, Arjun. Try the second one. Del square phi is equal to 0 is given in the first question. So use that. What is del square phi? Double derivative of phi. Okay. Dou 2 phi by dou x square plus dou 2 phi by dou y square plus dou 2 phi by dou z square. That is what you're gonna get. Double differentiation of this function with respect to it is equal to 0 they have given. Okay. Indirectly. The double differentiation of the first function is what? 2axy into again differentiation will be 2ay minus double differentiation with respect to y will be, for this function it will be 0, for the second function it will be minus 6y equal to 0. This is what you are going to get. So y will get cancelled. 2a is equal to 6. It means x a is equal to 3. That's all. And second one minus 12 is the correct answer. What they have said is solenoidal. Solenoidal means the divergence of the vector is 0. So if you take a dot product, is phi x. Okay, differentiation of this with respect to x is phi. Differentiation of this with respect to y is lambda. Differentiation of this with respect to z is 7 equal to 0. So lambda is equal to minus 12. That's all. Okay. What is del dot f bar? It's like dou by dou x of f1 dou f2 by dou y plus dou f3 by dou z equal to 0. This is what we are saying. Okay. Let me give you another question. Tell me the answer for it quickly. F bar is equal to 5x square zi, okay, minus 7xy square j plus 12x plus 7z times k, 12x plus 7z times k, then del dot del cross f bar at 5 comma 3 comma minus 2 is
0.
yes, answer is 0, right? Because indirectly what we are calculating is divergence of curl of vector. Divergence of curl of vector we are calculating, and we know that we have studied divergence of curl of vector is 0. If you want to try, you can try also. Del cross f bar first calculate it, which is I j k dou by dou x dou by dou y dou by dou z, and it is 5x square z minus 7x y square 12x plus 7z. Okay, take a determinant of it. So ultimately what you will gonna get is 0i plus 12 minus 5x square j plus or minus 7 y square k. This is what you will get, minus 7 y square k. And again, if you take a gradient of it, differentiation of this with respect to y is 0, differentiation of this with respect to z is 0, so you're gonna get your answer as 0. Okay, so yeah, so this is what you can expect from the divergence and curl point of view. Okay, mainly they will ask questions related to the irrotational vector field or solenoidal. So you should know what is the meaning of it, and some direct questions also they may ask, like calculate the divergence or curl of this vector and so on. Okay, yeah, and yeah, so that's all we have from the vector differentiation point of view. Okay, so we have some more time available, so let's start the vector integration, at least the introduction part, and some basics we'll learn, and then later we'll continue in the next session. Okay, so write down heading vector integration. Write down heading vector integration. So we'll study first what is line integral, surface integral, volume integral, and etc. Okay, and some of the theorems associated with it. Okay, in this vector integration we have to study three theorems, three types of integrals, and these theorems will help us to interchange from one type to another. So first type is line integral. An integrator or an integral which is evaluated over a curve is called as a line integral. Okay, suppose if we have a curve C, then we say integration over a curve C is shown like this. Integration over curve C, f bar dr bar is given by f1 dx plus f2 dy plus f3 dz. Okay, where f1, f2, f3 are the uh, magnitudes along x, y, z direction. So your f bar is x1i plus f1i plus f2j plus f3k. Okay, considering this, this is how we can write the line integral. What is C? C is the closed curve. If C is a closed curve, then this integration is, you can call it a circulation, and then you can use this symbol, integration over a closed curve. So whenever we use this symbol, then this C is called as a closed curve. Okay, and if it is not the case like this, then it's just the curve. Okay, I hope you understood the difference. So whenever this circle is used, its meaning is over a closed curve C. If it is not used, it's just curve C. Okay, and what is f bar dot dr bar is f1 dx plus f2 dy plus f3 dz. That's all. Work done by a force f bar. Okay, the total work done by a force f bar in moving a particle along a curve C is given by this. Okay, so f bar is the force you are applying, and dr bar is the distance traveled by the particle. Okay, then um, along this curve C. Okay, then integration over curve C f bar dr bar will give us the work done by force P in moving a particle along the curve C. Okay, if f bar is irrotational, okay, some more points. If f bar is irrotational, then the line integral of f bar is independent of the path. Okay, so irrotational in the sense you have curl is equal to 0. Okay, so means your vector field is not rotating. In such situation, if you take any path for the integration, then so for example a to b you are integrating, so irrespective of any um, uh, any path if you take, ultimately you're going to get the same answer, because it is not depend on the inner uh, values. It's just final value minus initial value integration. So you can write it as a definite integral a to b f bar dr bar. So it is a, let's say, phi b minus phi n. That's all. Okay. Yeah. Okay. So this is also one more point. Let's take some questions to make this concept robust. Um, let me give you one question here. The value of integration over curve C f bar dr bar, where f bar is equal to 3xy I minus y square j, and C is curve y is equal to 2x square, joining points 0, 0 and 1, 2. Okay. Yeah, that's all. Solve it. What they're asking is the find the value of the integration over curve C f bar dr bar, where f bar is given, that is 3xy I minus y square j, and C is the curve y is equal to 2x square, joining the points 0, 0 and 1, 2. 0, 0 and 1, 2. All this question. Yeah, so as I said, integration over curve C f bar dot dr bar is equal to integration over C f1 dx plus f2 dy plus f3 dz. So this is your f1, this is your f2, and f3 you don't have here. So f1 is 3xy integration over curve C 3xy dx minus y square dy. Okay. Um, okay. Integration over curve C means it's like from 0 to 1. Yeah. Because see, try to understand here what you are doing. Your point of interest is 0, 0 to 1, 2, and your integral is also in terms of x and y. So ultimately we have to convert this entirely into one variable problem. So how can we do it? If you put y is equal to x square, okay, because the curve equation is y is equal to 2x square, dy will be 4x dx. So using this approach, I can write 3x into 2x square dx minus 2x square whole square into 4x dx. So ultimately I can write this integral as integration 0 to 1 6x cube dx minus 16x raised to the power 5 dx. Okay, so that is 6x raised to the power 4 by 4 minus 16x raised to the power 6 by 6. Okay, put the limit 0 to 1. 6 by 4 minus 16 by 6, it's minus 7 by 6 what you should get. Okay, minus 7 by 6 is the final answer. Okay, we got a question from Arjun how I have to these limits. Um, what they are saying is a curve C is y is equal to 2x square joining the points 0 comma 0 and 1 comma 2. Okay, so what is the equation of the curve? 2x square. Okay, so if I want to convert this equation entirely in the form of x, um, so how x is varying? X is varying from 0 to 1 itself, right? So that's why I have written 0 to 1, and in place of y what I am writing 2x square. So that's how I have converted entire problem from two variable to a single variable, because they have given us the relationship between x and y. Okay, um, I hope you understood. If y is equal to 2x square, then dy will be 4x dx. So rather than writing, let's say 0 comma 0 to 1 comma 2, this kind of limits, um, we can convert them entirely into um, a single variable problem. Okay, is it clear? Or let me help you with one more question, then things will be clear to you. Okay, let me give you one more question. The value of similar question, integration over curve C, f bar dot dr bar, okay, where f bar is equal to 3xy times I minus y square j, and C is curve bounded by y is equal to x and y is equal to x square. Okay, y is equal to x and y is equal to x square. Yes, it's okay. I'll help you with this figure to make you understand what they're asking. Y is equal to x square is the parabola. Y is equal to x is this inclined straight line, right? So this is y is equal to x. This is y is equal to x square, and curve bounded by these two means this is the curve they are targeting. This one and then this one, just like this. Okay, from 0 comma 0 to 1 comma 1. Okay, so you can call it as a C1 and call it as C2. Integration over curve C, f bar dr bar is equal to integration. Basically, you have to do it over C1 first. Okay, some terms inside, and then integration over the curve C2 like this. Okay, because this is a closed loop, and if you add them, ultimately you should get the same answer. At least this first part, let's call it as I1 and this I2. How the I1 will look like? Integration over curve C1, f bar dot dr bar is equal to integration over C1. What is f bar dot dr bar? F1 dx. So differentiation of 3xy with respect to x is a 3y. Just a minute. F bar dr bar is equal to 3xy dx minus y square dy. Okay, and if you integrate it now, but yeah, limit is what x is varying from. See, look at this 0, 0 to 1, 1 point, and you can convert this integral like a 0 to 1 with as you are considering the curve y is equal to x square. Okay, um, y is equal to x square means dy will be 2x dx. So I can write this as like 3x into y is x square, so it is a 3x cube dx minus y square means x raised to the power 4 and dy means 2x dx, and then if you integrate it, it will be like how much? Yeah, 3x raised to the power 4 by 4 minus 2 x raised to the power 6 by 6, 0 to 1. Okay, and it's ultimately 5 by 12. Okay, this is your first integration. In a similar way, calculate the second integral. Second integral is quite simple. Integration over C2 f bar dr bar will be integration over C2, means again from 0 to 0, 0 to 1, 1, but through the straight line, which is y is equal to x, means dy is equal to dx. As simple as it is. So it's again 3xy dx minus y square dy. I can clearly write it as integration 0 to 1, 3x square dx minus x square dx again. So it is a 2x square dx. Okay, so if you integrate it, it is a 2x cubed by 3. Putting the limit 0 to 1, it is sorry, it's 1 to 0. Yeah, because this is like a 1, 1 to 0, 0 like this, and it will be minus 2 by 3 you should be get, and so integration f bar dr bar is equal to c1 plus c2, that will be 5 by 12 minus 2 by 3, it is minus 1 by 4. Yes. Yeah, 5 by 12 minus 2 by 3 is 1 by 4. Okay, any doubt till this? Let me see if we have any other. Yeah, I'll just give one homework question to you. You can try it whenever you get some free time related to this. Integration f bar dr bar, where f bar is 2y plus 3 times I plus xyj plus yz minus xk. Okay, along the line joining, first is 0, 1, 0, 0, 1 and 0, 1, 1. Okay, and the second part of this is 0 comma 1 comma 1 and 2 comma 1 comma 1. Okay, answer for the first question is 0, whereas second question is 10. Okay, solve this whenever you get some free time. Yeah, and yeah, in the next class, on weekends, we will focus mainly on the theorems. Gauss's theorem to convert the cyclic integral or yeah, integration over a closed loop to the integration over the region. So we'll convert the single integration into the region integration, where we'll use our understanding of double integral, multiple integration basically, which we have studied. And then another point will be the surface integral, where we will study again um, one more theorem, okay, and which is Gauss divergence, and then we will study the volume integral. Yeah. So basically, Gauss divergence will help us to convert a surface integral into a volume integral problem, and then the Stokes theorem. Okay. So this is basically the overall idea about the topic. Okay. So currently we are just working on the line integral. Then we have to work on surface and volume integrals as well, and the theorems associated with. That's all. Okay. Any doubt till this? Yeah. Okay. Then if no doubts, we'll end our session here and again continue on Saturday. Uh, yeah. I hope in the next class we will complete this vector vector calculus topic. So thank you all for joining this session, and let's meet again on weekend. Thank you. Good night.